In previous examples, we learned that Markov chain at present state. So for example, the transition probability of transition to state J from state I only depends on I, but not the past states, only the current state I. Okay, so now let's learn what happens if it's not the case. So how do we transform a stochastic process to Markov chain? That's like so future state only depends on the current state. So this is our setting. That is, let's suppose that the weather is still like either rain or not rain. So the weather is rain or not rain. And however, so whether it rains today, it depends on previous weather in the last 2 days. Okay. Instead of a intermediate, depends on the weather of last 2 days. So how do we transform this stochastic process to a Markov chain? So let's still denote using this R as it rain and S as not rain. All right. So and we have the following setting: the probability of given it has rained for the past 2 days. So this is rain, and let me emphasize this is today, and this is yesterday. Okay. So it has probability of raining, and this is tomorrow. Oops. And this probability is 0.7. Okay. So the probability of it rained today but not yesterday, okay, then it will rain tomorrow with probability 0.5. Okay. So let's suppose if it rains yesterday, but today we have sunshine, then it will rain tomorrow with probability 0.4. So lastly, if today we have sunshine and yesterday we have sunshine, then tomorrow we have only 0.2 chance of rain. Okay, so upon this setting, so first of all, this is not a Markov chain because the dependence is not with your intermediate neighbor. Okay, so but however we can transform it into a Markov chain by using the following. So instead we have rain or do not rain. So 2 states, we create 4 state. So let's say state 0. So if it rained both today and yesterday, so okay, and we create state 1. It means it rains today, but not yesterday. Okay. So then we create another state 2. Okay. So that is it rains yesterday, but not today. Okay. And then we have our last state, which is state 3. So it did not rain yesterday, nor does today. Okay. And what happens is we suddenly can transform this into a Markov chain. So for example, now, so let's first we consider state 1, state 0 to state 0. Okay. So this might be a little bit confusing, but let me first write down the numbers. So this is 0.7, and it is actually the same with the first probability right here. So y, and let's add this remark. Okay, so so this one is like today. Okay, and this is yesterday. So however, when we consider the state for tomorrow, okay, this one, which is today, okay, but it is yesterday for tomorrow. Okay, and this is tomorrow. So tomorrow is like today for tomorrow. Okay, so and let's look at next. Is from so given that today is raining, so what about we're moving to state 1? So from state 0 to state 1. Okay. All right. So this is like today. So if it rains today, and for tomorrow it should also rain, which means this is impossible. So this transitional probability is actually 0. So given today we have rain and yesterday we have rain, and so this RS, so this R means it's gonna rain tomorrow, but today is yesterday for tomorrow and it's sunshine, so it's impossible because these two are like contradicting to each other. So this is 0. Okay. And next is we want to find that so this is it is raining today, and it rained yesterday, and so right here, so today is yesterday for tomorrow, and this is tomorrow. So then given it is raining for 2 days and tomorrow it's going to be sunshine, it's nothing but 1 minus the previous probability, which is 1 minus 0.7, and this is 0.3. Okay, so lastly, we work on SS and RR. So using similar logic, because so today is raining and today is yesterday for tomorrow. So then this transition is impossible, and we have this is 0. Okay. So using following logic, so here I'm gonna write down the full transition probability matrix. So it's gonna be 0.70. So we just verified our first row is gonna be 0.70, 0.30. Okay, so as we can see, we have row sum equal to 1. And the next, so I'm gonna write down the numbers, and the verification is left as exercise. Okay. So using similar logic, we can obtain the rest transitional probability, and this is how we convert a non-Markov process to Markov chain.